Hello, team. Today we're going to be talking about these lines. So we're going to be dealing with some more lines, trying to get this ready here for you. And we're going to talk about different ways to write equations of lines today. So today we're going to practice more with writing the equations of lines. So here's a warm-up, and a lot of you were asking me about this because this did show up on the homework, and we probably will be talking about this right before this in class. Is this a linear relationship? How do you know? Okay, so the thing that you're looking for in a linear relationship, if you have a table, is you're looking for a constant rate of change. What that means is no matter what 2 points that you pick, no matter what 2 points you pick, the change in y over change in x, that slope formula will be the same thing. So what you could do, and this would take a lot of time, is you could test these 2 points, test these 2 points, test these 2 points, test these, until you get different numbers. And then once you get different numbers, you can say, oh, not linear. But if the x's are spaced out nicely, then you would be able to just look for the plus 2, plus 2, plus 2 type of thing, which that's not the case here because they're not spread out nicely. But you have some that are spread out nicely. So what you can look at is from here to here. That is a nice little one step. And what is the rate of change? That's a plus 2, right? So if I went plus 1, it was a plus 2. Now from here to here, then I went plus 2. So if you took 2 steps, then that would be a plus 2 plus 2, which is plus 4. And so far, the rate of change is the same. And then here, once again, you went plus 2. And then once again, you did go plus 4. So yes, it is linear. Other options, yeah, you could graph it if you wanted to graph it to see if it's linear. Just be very careful. Your graph would have to be perfect. But that's kind of what we're looking for with linear relationships. It's significantly easier when the x's are spread out nicely. I'm going to turn on my fan 1 second. Sorry, I just ran up the stairs and I forgot to turn on my fan. So here we go to the next slide. Okay, so this is from yesterday or whenever you last saw me. These are the forms of a line. We have slope-intercept form. We have standard form, which was a little bit different, we said this time, point-slope form. Okay, so those are our forms. And let's take a second here and look at this guy. So what form is it? It's point-slope. You can tell by its looks and that it says it right here. So what do you know? Well, by looking at this, things you should be able to tell me is, yep, the rate of change shows up right here. That slope is 3. Then you also should be able to tell me that there is a point on that line, and that line's point is at change the x, -1, change the y, +5, -1, 5. You probably could tell me the y-intercept if you just went ahead and cleaned it up, and that would be y minus 5 is 3x plus 3, add 5. So you might be able to tell me that the y-intercept is 8. And when we do the y-intercept, we're going to write it as a point with the x value at 0 and the y-intercept showing up at 8. Okay, at the end of this, what are we going to be able to do? We're going to talk about points, slope, and intercepts, and write their equations, and we're going to solve some problems. Okay, when you write equations of lines, all you really need is M and B. I say that a lot just because it helps me remember what I'm looking for, but there's lots of ways you can be given this. You can be given a point and a slope. You can be given 2 points because that secretly tells you the M, and then that would be a point given to you. And there's lots of ways this could look, and that's what we're going to practice today. So here, we're going to write the equation of this line. So all you need is M and B, which would be the y-intercept and the slope. So let's look at what we have here. Definitely you can see the y-intercept clearly, and that's at 4. And we can find the rate of change or the slope by looking for the rise over run. Remember, y is up top. It's that delta y over delta x. So what you're looking for are some lattice points. Lattice points happen right on the crosshairs, like that one we said, and this guy right here. It is an uphill line, as positive slope, and the rise is 2, and the run is 1. Well, all you need is M and B, and now you can write an equation of a line. Y equals mx plus b, plug in what you know. Y equals 2 for the slope, x is always there, plus 4. That is slope-intercept form. If you were going to do point slope, you could use the point I just used, the 0, 4. You could use this point right here. That would be -1, 2. Any point, your equation could look different. So if I use this point, it would be y minus y1 equals m. We just calculated. So you would have to calculate the slope no matter what. X minus x1, which would be x minus 0, which you probably wouldn't write the minus 0 because that's a little extra. So maybe y minus 4 equals 2x. Okay, and that looks weird, but technically it would be point slope. It would look more normal if I picked a point such as this. Y minus y1 would be y minus 2. M, that's slope. X minus x1 would turn this to a plus 1. You could clean that up, and it would look like what we have here. Standard form, we usually would not choose to write that way. For me personally, I would go to mx plus b and then rearrange it. Remember, this text actually wants your a value, the one in front of the x, to be positive. So if you wanted to do that, it might be easier to subtract y and subtract 4. I'm doing 2 steps at once there. So that's -4 equals 2x minus y. If you didn't do it that way, you could have moved the 2x first, which is probably what I would have done if they didn't have the a positive rule. And it would look like that. And then you would divide all the friends or multiply all the friends, whatever you'd like to do, by -1. 2x minus y equals -4. So given a line, you can write the equation in all the different ways. The easiest, in my opinion, would probably be mx plus b, but sometimes the y-intercept, you can't quite tell where it is. And sometimes point slope is a little bit better in cases like that. But standard form, I would just skip from switching over from one form to the other. More practice. So this is the one I'm kind of talking about. All you need is m and b, and unfortunately, the y-intercept is kind of hard to see here. So in this case, I'm probably going to go the slope first. I'm going to look for those lattice points like we talked about. Here's a nice one, and here's a nice one. This is a downhill line. Kids forget their slopes, negatives, and positives sometimes because the change in y is a negative. So I'm going to go down 1, 2, 3, 4, 5 over 1. So it's a -5 over 1 or -5. Y-intercept, I don't know. So I'm not going to do mx plus b just yet. I'm going to hold on to that for a minute. And I'm going to see what I do see nicely, which is this point here at 2, -3. So I'm going to go with point slope first. And we will get y plus 3 equals m, which is the -5, x minus 2. From here, I now can find my y-intercept. I can just clean this up. Y plus 3 is -5x plus 10. And then you would subtract 3 and ask yourself if it looks reasonable. -5x plus 7. Does it make sense that the y-intercept could be up at 7? And I think it does. Now, I told you that this formula is not good if you don't know it. How could I get this question right if I didn't know the formula? The other option you could have done is said, okay, I don't know what b is, but I know this point 2, -3 is on the line. If you know that, what you could do is you could use this for x and this for y because it's a point on a line, this for m, to find b. So you could say -3 is -5 times 2 plus b. That's -3 is -10 plus b. Add 10, and you can see that b would have to be 7. Now you know the m and you know the b. You can write the equation the way we need to. I do sometimes opt to go this route. Now, Mrs. Bruno definitely knows her formula, though. So you can survive with just mx plus b, but point slope would be a more direct approach. After you know the slope-intercept form, you can change it to standard. Let's move the x over by adding 5x. And I get 5x plus y equals 7, and that is standard form because everything is, the x value is positive like they want. Okay, more practice. We're going to write equations now that give you the intercepts. If they tell you that the x-intercept is -9, the y-intercept is 4, what is the equation? So what are your strategies here? I will have some students that will insist on graphing this. And then figure out the equation from there. Nothing wrong with that, except if your graph is not neat, you could mess up with your slope or something. Okay, the graph might help some of you to write this as a point though, and x-intercept means the point. X-intercept means y equals 0, -9, 0 is on the graph. Y-intercept is telling you that b equals 4, so that much you know, but that would be x equals 0, y equals 4. Given 2 points, now that you know b, and remember all you need is m and b, you can find the slope, the change in y over the change in x. Some of you like the y2 minus y1 over x2 minus x1. That's fine too. So 4 minus 0 over 0 minus -9. Make sure you go from one point to the other, one point to the other. This becomes plus a positive, so the slope is 4/9. Once you know m and b, you can write the equation 4/9x plus 4. Kids sometimes forget their x. Make sure you're not forgetting their x. There could be other ways that you attack that problem. And if you're not getting the right answer, please reach out to me and we can make sure that your method is valid. Okay, writing equation of line given 2 points. Okay, so this is very common and kids do struggle. Just don't lose sight of what you need. All you need is m and b. So I have 2 points. I don't have either because none of these are the y-intercept. So what the first thing I'm going to try to find is a thing I can find, which is the slope. Using these points, I can find the slope, the y2 minus y1 over x2 minus x1. That will be 5 minus -7 over 1 minus 4. This gives me 12 over -3, and my slope is -4. All you need is m and b. Now you have 2 options from here. Mrs. Bruno usually does go with the mx plus b. A lot of you will go with the y minus y1 equals m x minus x1. Okay, I'm going to go both routes so you can pick which way you like to do. I would not do both all the time. I would try to get a feeling for which one you like best and stick with that. So I know the slope is -4. So right now I have y equals -4x plus b. And I need to find b, and I have x and y here. So I'm just going to pick my favorite point. Which one do I want to use? I can pick. I think that this one is best. It's positive. I'm less likely to make a sign mistake. So the other one will get you the same answer as well. So y is 5, -4 times 1 plus b. Plugging this in for x and y into my equation. If 5 is -4 plus b and I add 4, b is 9. All I need is m and b, and I do get -4x plus 9. Other routes would be this guy. And again, I can use any point I wanted to get this. Y minus y1, I'm going to use this point, 5. It's m, we just calculated. So no matter what, you would have to find the slope first. X minus x1, which is x minus 1. Clean up. Oh, was that a choice anywhere? No, that wasn't a choice anywhere. Y minus 5. Nope. All right. So this is y minus 5 is -4x plus 4. Add 5, just like the other, -4x plus 9. Now we got to see what other ones of these are right. Well, this one's definitely not right. -23 is not the y-intercept. You probably could tell this one is not right as well. What they did here was they plugged the x, they took the y value and plugged into the x. Could this be a possible answer? Well, they were definitely playing around with the other point here, x minus 4, and that would be y plus 7. If I clean this up, -4x plus 16, subtract the 7, I am going to get the same answer. So this is also a possibility. And if I get y by itself here, this is just standard form, also works. Now, once again, every year I will have a child who tries to graph this and calculate from there. 4, -7, and 1, 5. There's a lot of information you can get from here. You know it's a negative slope line. You can kind of estimate where that y-intercept would be. This is not horrible, but it's not best when you're graphing your own line, okay? If it is a multiple choice, it's a valid strategy because you probably can get rid of all these wrong ones. But you really need to be able to work with the equations. Okay, parallel lines and perpendicular lines. What you need to know about this is slope measures how steep a line is. And parallel lines, which look like railroad tracks, have the same steepness. They're just moved up or down. These don't even look parallel. Doesn't that look like it's leaning in my, I might have stretched my picture a little bit. The slope is 2, yeah, okay. My picture might be stretched a little bit so it doesn't quite look right. So parallel lines have equal slopes because their steepness is the same. Now, perpendicular lines, in case you don't remember, the symbol is upside down T. Those make right angles, don't forget. They definitely don't have the same slope. In fact, if one is positive, the other one has to be negative. So for starters, they say negative. I don't like that. I like to say opposite reciprocals. Because if one is negative, one would have to be positive, and I think it's better to say opposite instead of negative, but it's up to you. So they definitely have one positive, one negative, and if one is steep, the other has to be a little bit flat. So they're reciprocals of each other. And the example is 2. If the slope is 2, the perpendicular slope would be negative. The reciprocal is the flip of that number, 1/2, a little steep, a little flat. If the slope is negative 2/3, the perpendicular slope would be opposite, so it's positive. The reciprocal is 3/2. So that's what we're dealing with next. So if they ever tell you that a line is perpendicular or parallel to another line, they're telling you in disguise what the slope is. So let's practice. A line has this equation. What one will be parallel? Well, they're telling me the slope. So I need to find the slope of this line. 3x minus 4y equals 1. The best way to find the slope for me is to get y by itself and put it in slope-intercept form. Negative 4y is negative 3x plus 1. Divide everybody by negative 4. Be careful with your signs here. And you get y equals 3/4 x minus 1/4. Which one is parallel? Parallel has the same steepness. So if the slope of this line is 3/4, a parallel slope is also going to be 3/4. So we're just looking for lines that have 3/4 of slope, and this is the answer. Next, write the equation line that goes through this point and is perpendicular to this guy. So all you need is M and B, or a point and a slope. I have a point, but I do not have a slope. But I actually do because they're telling me that it's perpendicular to this guy. So I need to know what is the slope of this guy, and then I can find the perpendicular slope. So I'll get y by itself, and I'm going to move the 2x and the 1. So it's just negative 2x minus 1. I just subtract both pieces. So the slope of this guy is negative 2. So then what would the perpendicular slope be? Well, it'll be the opposite, so positive. Reciprocal is 1/2. So my new slope is going to be 1/2. I don't know the y-intercept, but I do know that negative 5, 5 is on the line. So now you have the two choices again. Y minus y1 equals m, x minus x1, or y equals mx plus b to figure out what the b is, or just plug it in the formula. If you went this route, it would be y minus 5 is 1/2 x plus 5. You could probably leave it like that, or you could clean it up if you want. If you went this route, y, you would plug in your point for x and y. 5 is 1/2 times negative 5 plus b. 5 is negative 5/2 plus b. That's negative 2.5, negative 2.5. So if I add the 2.5, my b is going to be 7.5. Okay, so I can write, I'm going to write with decimals just because then they're both in decimals, 0.5x plus 7.5. If you went this route, you'll get the same thing if you clean it up and put it in slope-intercept form. Okay, what do we have here? What if it's parallel and not perpendicular? Well, I already figured out what the slope was. Y was negative 2x minus 1, if you remember. So the slope of this was negative 2. So a parallel slope would also be negative 2 because they would be the same. So now you'll do the same thing again. Y minus y1 equals m x minus x1, or y equals mx plus b. You'll go one of those two routes. If you went this route, y minus 5, the slope is negative 2 because it's the same as the other, x plus 5, and you could clean it up from there. Or, sorry, what is the y I'm wanting to plug in here? This is x and this is y. 5 equals negative 2 times negative 5 plus b. 5 is 10 plus b minus 10 minus 10. Negative 5 equals b. Now, you know m and b, you can write y equals negative 2x minus 5. Again, if you clean this one up, you would get the same thing. Y minus 5 is negative 2x minus 10. Add 5, y equals negative 2x minus 5. So it doesn't matter which way you go, you'll get the same answer. Okay, little word problem. An online bookstore is having a sale, and all books are being sold for the same price. So Kendra got 3 books and paid $23.50. Marvin got 5 books and paid $33.50. Ling ordered 2 books, paid $18.50. What is the total cost for 15 books? Okay, there's a couple routes you could go here. Actually, if you really wanted to, you probably could just take the 5 books price and multiply it by 3. You get there. But I think we're supposed to write an equation of line, so we're going to go ahead and do that. What they're telling us here, they're telling us points. They're telling us that 3 goes with 23.5. They're telling us that 5 goes with 33.5. And they're telling you that 2 goes with 18.5. Now, you guys are all good problem solvers. Some of you would divide this by 2 right now and get the rate of change. Perfect. You could be really formal and do the slope formula. Also perfect. But if I'm going to write an equation, I'm looking for mx plus b here, right? So the other thing you could do probably is make a table and go with it from there too. I don't want to limit you what you're doing, but let's go ahead and use 2 points here. Let's use these 2 points. The slope is going to be 33.5 minus 23.5 over 5 minus 3. That's 10 over, I put a 2, 10 over 2, which is $5. So the slope is going to be $5 per book. Now, there must have been some sort of initial condition, I'm guessing, maybe a shipping or something like that. So let's see what's going to happen here. So you can do point slope. You can pick one of the points, or we can just pick a point and plug it in and find the y-intercept. So let's do that. 23.5 is 5 times 3 plus b. That's 15. I'm going to subtract 15 from 23.5, and that's 850. So the y-intercept was 8.5. So yeah, so my what I told you about dividing by 2, that would have been bad because I didn't realize that we were on an online bookstore and there was some sort of initial condition. But what we have is what? 5x plus 8.5. Yeah, there's probably some sort of shipping fee, okay? Or a membership fee just for using the service. So be careful on problems like that so you don't do Mrs. Bruno's bad advice there. If you would have graphed it, you would have saw that there would have been an initial condition or a y-intercept. But read the question carefully, because my suggestion of taking 18.5 and dividing it by 2 would say that each book would have been 925. If you would have checked that, if you take 5 times 9.25, you would see that's wrong, because that would have been 46.25. So just make sure you're reflective if you're problem solving with a non-typical strategy, so that you don't make us silly. Okay, another word problem here. A computer technician charges a flat rate. So that would be your initial condition, plus 55 per hour. That's the rate of change. They billed $190 for a 2-hour visit to install a new hard drive, and they wrote this equation with a little extra square there. Y minus 190, so they plugged that point in, is 55. That's the rate of change, x minus 2. What would the equation be in slope-intercept form? That's not bad. Let's just move it around. Y minus y90 equals 55x minus 110. Add 190. Looks like 55x, there's that hourly fee, plus 80. That must be the flat rate for the home visit. What would that y-intercept represent? That initial condition, that $80 flat fee, flat rate. If the technician charges $327.50, how many hours would they work? Well, now we're just going to use our equation. This is the total. So that's $327.50 equals that rate we just figured out, 55x plus 80. So subtract the flat rate from the cost because that will tell us how many hours they worked. $247.50 is how much they got paid. 55x divided by 55. You get 4.5 hours. Okay, so that's a little initial condition problem for you to look at, that they started with point slope. Okay, here's all the summary of everything we talked about today. Slope-intercept form, point slope, writing equations of lines, some steps. If you want to put some steps in your notes, you can do that as well. And how do you go with the word problem? Okay, that's it. Please let me know if you have questions.